Okay, thank you very much. It's a pleasure to be here, and I really appreciate and want to thank the organizers for having this symposium and for inviting me to be a part of it. I am not somebody who grew up thinking about going to Antarctica. In fact, I did not think at all about going to Antarctica. My main focus intellectually was definitely mathematics. I loved math, I loved the precision, I loved the simplicity, I loved the power of math, I loved the beauty of math. I was enthralled by the fact that a really difficult sounding problem could become so simple simply by putting it into the appropriate symbolism. So math was definitely my key interest. However, I graduated from Wellesley College in math, but then I did not pursue. By the time I graduated, I knew I couldn't continue in math, and I knew that I would have to get out of the theoretical realm, and the reason was because of everything else going on in the world at the time, and the fact that I just couldn't divorce myself from it. This is Montpelier High School. I had similar problems to Kelly in terms of girls were not allowed on any sports teams, which was very unfortunate. But there were lots of boys' sports teams. Wellesley is an all-girls school, so we were allowed on any of the activities at Wellesley. So, however, as I said, by the end of Wellesley, and even though I loved math, it was definitely my prime interest. I knew I couldn't stay in it, and that was because of the extreme injustices that were all over at this time. This was the 1960s, and I graduated in 1970, and the civil rights injustices were horrifying. There are some that continue today, clearly. There was a war going on in Vietnam that was very troublesome, very controversial. There were some highlights, the stirring words of Martin Luther King and the entire civil rights movement, which I still consider to be the most important and most purest of any cause I've been involved in. And then other highlights were the huge technological achievements from the Mercury, Gemini, and Apollo programs, leading to the landing of men on the moon in 1969, only 9 years after the very first human was launched into space. So an amazing achievements there, where the US did have something to really applaud at that otherwise very difficult time. The difficulties were significant enough to me personally that I did end up missing my college graduation because of being in jail. So although I did not protest the playgrounds like Kelly did, I did protest other things. But I did, after college, then have to decide, what am I going to do next? And the thing that really appealed to me was the Antarctic Treaty. The Antarctic Treaty, preserving an entire continent for peaceful purposes only, had a huge impact on me. And I decided I want to go to Antarctica. Well, at that time, there was no Google, there was no internet. I couldn't go Google, how do you get to Antarctica? So I went to the library. And I went to the library, I tried to figure out how to get to Antarctica, and the place that kept coming up over and over was Ohio State's Institute of Polar Studies. So I wrote a letter to the Institute of Polar Studies. I did explain that I had absolutely no background in earth sciences at all. I had never taken a geology course or a geography course or a meteorology course, any course related to earth sciences, but I did have a very strong academic background, and I really wanted to go to Antarctica. Well, fortunately, For me, Ohio State and the Institute of Polar Studies, the Department of Geography, and John Rayner accepted me as a graduate student based on my academic record in other topics. And so I came to Ohio State and hugely appreciate the fact that they would risk taking somebody who really did not have the standard background for this type of work. And then the person that has really, the person who got me to Antarctica was Terry Hughes. Terry Hughes was an associate professor at Ohio State at the time, working at the Institute of Polar Studies. And he knew that the reason I came to Ohio State was to get to Antarctica. And he decided, well, he'd take me on his expedition. Now, to add to how much I appreciate Terry for doing that, not only was he willing to take a woman, but I ended up passing out during the physical. And this was not like a one-time thing for me. I have a history since, all my life. I occasionally pass out, occasionally have grand mal seizures. Terry knew that, and yet he stood up for me. I got a letter from NSF saying that I was disqualified because of the physical. And I was very discouraged. I went to Terry the next morning. I said, Terry, I can't go. NSF has rejected me. And if there's anything I can do from here at Ohio State to help out, I would love to help out in whatever way I can possibly help out. And Terry said, can I see that letter? And I said, sure. So I gave him the letter. He read it and he said, do you still want to go? And I said, of course I still want to go. And he said, well, we're going to fight this. And I appreciate Terry because he did fight it. There was no way I was even thinking about fighting it. I just thought I blew it by passing out. But Terry fought it, and I really appreciate NSF also for changing their decision on that. So in both cases, I really appreciate this. This was well before the 1990 Americans with Disabilities Act, and so really NSF did not have to change their mind on that. Terry did not have to fight for me. So I really, really appreciate them. Unfortunately, Terry is deceased now, but the next most important person on that expedition, Terry's right-hand man, is still alive. It's Henry Brecker, who is in the audience right now. And what we were working on was, well, Terry was very much concerned about the stability of the West Antarctic ice sheet. It was wonderful talking with Terry on that topic. He explained to me all sorts of things that I did not know about at that time. Explained about how the West Antarctic ice sheet is grounded below sea level. That inherently makes it subject to more instability than the East Antarctic or than Greenland. And so his expedition was to Deception Island, and we were going to measure the flow of ice back into a volcanic crater. Deception Island is volcanic, and so Deception Island is volcanic and had exploded. There had been eruptions in 1967 and 1970. And so we were going down to measure the flow of the ice back into a crater. Here I've got a slide that honors the pioneering women that we're honoring today, the four from 1969, and the article about that the Ohio State's Lantern newspaper put out when our expedition to the Antarctic was being planned. And I note that in the last paragraph there, another graduate student here at the Institute of Polar Studies on his first expedition to the Antarctic was Lonnie Thompson. And he was going as an assistant to Ian Willens, who also has been mentioned earlier today. So this is the ship we went down on. I was the only female, and the guys were kind of joking around at various points. And we get down to Ushuaia, where we flew down to Ushuaia, and there's this lots of really big ships, and then there's this little ship there, and they point out to it and they say, Claire, that's the one we're going on. And I'm thinking, how gullible do they think I am? But that was the one. And that one, it's an NSF vessel called the Hero, and it ended up perfectly capable of transiting the Drake Passage, although most of us were badly sick the first 24 hours, but it did make it. This gentleman right there, Captain Lenny, he was infuriated with Terry for bringing a female. He did not know a female was coming. He was much more infuriated with Terry than with me, but Terry took it, and Captain Lenny, after a day or so, was okay. So, but he was infuriated to have a female on his ship. So, but anyway, we sailed down to the Antarctic and saw some beautiful scenery along the way. So there's along the Antarctic Peninsula. This is Deception Island, and on the left you can sort of see much of the island. It's an eruption thousands of years ago created the island, and it's essentially the water has come in from the Pacific into what was the crater with the breach in the rim there. And it is volcanic, so there is an area where there's a lot of steam, and that creates a really hot, scalding hot water right at the top surface and very cold water underneath. The rest of the water is really cold. So the challenge is to swim in this water by churning everything up. Henry was the first to go in, and after Henry did, I mean, the rest of us sort of had to. And certainly as the only female, there's no way I wouldn't take this challenge. But we did not swim long in this water, but we did get in and swim in it. Every day that was a work day, which was most every day we took Zodiac across. We were staying at a base, the Argentine base. There were had been three bases on Deception Island, a Chilean, British, and an Argentine. The Chilean and British bases were both destroyed during the eruptions in 67 and 70. And the Argentine base was the only one left. So we stayed at the Argentine base. There was a structure, there was no running water, but there was a well, and that's me walking up to the well, and you get a bucket full of water, and so that worked out just fine. And then here is the research site, and it's me and Terry on the left, and then three of the team on the right. And here's some more views of the research vicinity with Terry struggling down the very steep walls. There were stakes that we were, and here's the most obvious one is this one right here. There were stakes, and we were surveying to measure the movement of these stakes. We also got to see the main inhabitants of Deception Island, which are the penguins. Chinstrap penguins, there are thousands, many, many thousands of Chinstrap penguins on Deception Island. Here are some close-up views of the Chinstrap penguins, including one giving birth right there, this one. This then is the ship we came back on. It was hugely different from the ship we went down on, much more stable. This is a tourist ship, the Lindblad Explorer, and we got free passage back on the Lindblad Explorer in exchange for giving talks to the tourists. So it was a great deal for us. This is some of the people. I wish I had an actual photograph of our team, but there was only one female on the island, and that was me, so there I am. Terry Hughes is right here on the left. This is Olaf Orheim, who was leading a different expedition, not on Deception Island, but this was when we were all on Deception Island together, waiting for the ship to take us back. Then I came back to Ohio State, and Terry ended up moving to Maine, the University of Maine. So I no longer then worked with Terry, and I wasn't sure what I was going to do for my PhD. And then a scientist from the National Center for Atmospheric Research in Boulder, Warren Washington, came to Ohio State and gave a talk on climate modeling. I was not familiar at all with climate modeling. I sat there listening to his talk thinking, wow, this is something where if I could somehow get involved, I could maybe use more of my math than I'd been using up to then. So I went up to Warren after his talk, and after a discussion after his talk, I ended up going to spend the summer in Boulder working on trying to develop a sea ice model. His model was an atmospheric model. So I was trying to develop a sea ice model. By the end of the summer, my advisor at Ohio State, John Rayner, and I all decided this would be a great topic for a PhD dissertation. And so I ended up writing to NSF and getting a proposal funded for doing a sea ice model that became my PhD dissertation. So I got the degree December of 1977, and a couple of months before then, I went to a conference in Seattle on polar ice. I gave a talk about my model, and an individual from NASA came up to me, Jay Zwally, and he said, how would you like to work at NASA? And there is no way that ever in my mind had I dreamt that I could conceivably work for the agency that had done these amazing things by sending people to the moon, by sending spacecraft to Venus and Mars and Mercury, and had 2 spacecraft on the way to Jupiter and Saturn. And so it was just immediately my first choice of where to work. So I put in an application. It takes months to get the application accepted, but NASA did accept me, and I started work at NASA in July of 1978. Here's a set of new employees, 15 new scientists, 1 female. So it wasn't just Antarctic research that was not in balance in terms of scientific efforts. We were employed largely because NASA by that time had some satellites up, was getting data down, and had to figure out what do these data tell us about the Earth system. And so there were some people focused on what do these data tell us about clouds, others on vegetation, others on sea surface temperature, others on precipitation. I was in a group with Jay Zwally looking at what do these data tell us about sea ice. So sea ice is quite expansive. So in the wintertime, it covers roughly 15 million square kilometers in the Arctic, and that's 1.5 times the area of the United States. So clearly, no other means other than satellites really can get you a record that is consistent day after day after day. It's just too large an area. I mean, you cannot have aircraft going around this area 1.5 times the area of the US and get a record every day. You can't have people on the ground getting a record every day. In the Antarctic case, the winter time in the Antarctic, it's even more sea ice. It's 18 million square kilometers. So satellites were the way to get the really full picture of what's going on with the ice cover. So that was our object to do that. Now, the data at that time were nowhere near the type of data that we've got today with the satellites. The data, all the black areas here, that's missing data. And there's like even, I mean, you can see the big black areas, but there are lots of little black dots also, and all that is missing data. So we had a major effort to try to get these data into a reasonable state so that we could see something about the sea ice cover. But even with all the missing data, you can see where the sea ice edge is. I mean, it really does come out strongly on both of these images. So we knew we had something, but we had to make it a lot better looking than this. So we averaged to monthly averages, and that had a huge impact, and we cleaned up the data. So that's the kind of picture we came up with. September 1973, Antarctic sea ice concentrations. This was from an instrument that had been launched on the Nimbus 5 satellite in December of 1972. It got a record for 4 years. We spent 9 years analyzing that 4-year record, and in the process developed lots of means of how to deal with the satellite data. Now it's a whole lot easier. Computers are a whole lot faster. You've got computers on your desk that are far more powerful than the mainframe computers that had to be used at that time, where no computers were on desks at that time. So, so we came out with 2 books, the first on Antarctic sea ice, and Jay was the lead author there, and then I took over for the Arctic case, and those 2 books came out in 1983 and 1987. By that time, another instrument had a longer record than this 4-year record from the Nimbus 5 data, and that was the Nimbus 7 instrument that had been launched in October of 1978. And so then we could start looking at longer changes in the sea ice cover. And this is just a list of key satellite instruments. We use passive microwave instruments. A passive just means that it's not sending a signal down and receiving it back like a LiDAR or a radar. Instead, it's just passively receiving information. Microwave is the radiation type that we use. Visible radiation gets beautiful pictures of sea ice, but the problem is it has all the same limitations our eyes have. So with visible radiation, if there's a cloud in the way, you're going to see the cloud and not the sea ice underneath. And the microwaves, if you've got the right channels in the microwaves, it can go straight through the clouds. You can see through the clouds, get your data. And the microwaves are not reflected sunlight like the visible radiation is. So therefore, it doesn't matter if the sun is out or not. So whether it's polar night or polar day, we can get our data with the microwave. So since 1987, there's been a continuous string of satellites and of this type to establish a long-term record. In 1999, we had, by that time, we had an 18-year record that we published in a paper that these are the monthly averages. With the monthly averages, basically what you see is there's a lot more ice in the winter than the summer, which is not a huge achievement to figure that one out. So, but we wanted to see the long-term trends, and so we took out the seasonal cycle by having November only compared with the other Novembers, December only compared with the other Decembers. And when we did that, this bottom plot is the result that we got. And so now it's quite clear that the Arctic was showing a decrease in sea ice coverage. Now, right at the end of the record, in terms of what we were publishing at the time, there was some high values. So it wasn't 100% convincing, but certainly the trend was downward. And roughly the same time, also in 1999, a group from the University of Washington, led by Drew Rothrock, came out with a paper that analyzed submarine data and showed that there was a significant thinning of Arctic sea ice. So these two together ended up both buttressed each other. The satellite data were showing that the ice cover was retreating, and the submarine data were showing that it was thinning. And this combination helped make sea ice become kind of like a poster child of global warming. And that the fact that it showed that there's something really interesting taking place in the Arctic sea ice cover, plus the fact that people by then had computers on their desks, far more powerful. The satellite data were much better, much easier to handle, and very easy to get, or relatively easy to get. Then the situation changed dramatically in terms of how many people started using these data. So this is the record, then the 40-year record ending at the end of last year. And by now, the decreases in the Arctic sea ice are so much that you can even see it with the monthly averages. So that's a huge contrast. We do update every week, and so this plot goes up to October 9th, so last week, shows what the situation is right now. And switching back now to Antarctica, the Antarctic has a much bigger seasonal cycle than the Arctic. It's also got very different results than the Arctic. And here are the monthly averages. When you do the standard monthly deviations, you can see that for most of the 40-year record, it was basically increasing, and then dramatic decreases from 2014 on. So very, very different than the Arctic. The Arctic was so much more consistent with what people were expecting, and consistent with all sorts of other changes in the Arctic: warming of the atmosphere, warming of the land and the oceans, thawing of the permafrost, melting of the land ice also. And we do update the Antarctic also on the same website. And we do look at other things than just the ice extent. This happens to be a plot that I've done studies on the length of the sea ice season, and it shows that different regions, some are getting longer sea ice coverage and others shorter sea ice seasons. And this just emphasizes how big the change was from 2014 to 2017. The decrease in that 3-year period was 2.1 million square kilometers, which is greater than the Arctic decrease in over 3 decades. So the huge, huge decreases, very rapid decreases in the Antarctic. I have gone on other field trips. This is from the Bering Sea, where we're putting buoys out with radar transponders and tracking the flows. This is from the North Pole, where we took a plane most of the way, but hooked up with the dog sled team to get to the exact North Pole, measured the thicknesses there, did find some that were still over 4 meters thick. And this was from last year. This is from last year, ice bridge flights, which is bridging between 2 satellite missions, ICESat and ICESat-2. And this is me on my 70th birthday last year. That was cool to be there out on the ice on my 70th birthday. I'm also project scientist for a mission called Aqua, which does all sorts of things. It measures atmosphere, oceans, land, ice. It gets like fires, it gets hurricanes, it gets all sorts of things, and it allows me to realize that even if my own research might not be going well, the fact that this satellite is getting things that have been used in thousands of publications, even though most of the authors don't even know I exist, but still, it's been used in thousands of publications. It's been used in weather forecasting by NOAA and other agencies around the world. And so it's a wonderful sense of doing something of value. And the last two slides just show some results from the Aqua spacecraft, some pictures from the Aqua spacecraft on the Antarctic. So here is just from a few weeks ago with an iceberg calving off the Amory ice shelf. Two pictures from Aqua there, and then here's just the big time view from Aqua of the land ice on the left and the sea ice on the right. Thank you.